Hello everyone. This video is one of two videos where I'll be talking about Python variables, and in this video in particular, I'll be talking about basic data types. In this video, as well as future videos, for Python at least, I will primarily be using Jupyter Notebook files to demonstrate Python code since it will make it a little easier for me. But all the code I show you will still work in a normal Python file. Now let's get started. Programs need to use data in order to perform their functions. This data is stored in memory, and in order for the program to access, use, and/or manipulate the data, it needs a way to reference it. We can do this with the help of variables. Variable names can contain only alphabetic characters, numbers, and underscores, and they can never start with a number. I have a few examples right here. As you can see, we can have a combination of uppercase and lowercase letters, we can have underscores, and we can have numbers as well. Some examples of bad naming conventions. This one is still commented out. If I run this, for this one here, it's going to think we're trying to assign a value to another value. And so it won't see this as a proper variable name. See, it's saying it can't be a value can't be assigned to another value. But if we were to comment it out and then run it, we'll get a different error. In this case, it does sort of see it as a variable name, but it considers it invalid syntax because it starts with numbers. In Python, variables work a little differently than variables in a language like C++. I won't get too technical with it because I'd like to jump into the programming as soon as possible, but I'll give you a basic explanation that should still be enough to understand how it works. In C++, the data is stored in memory, and the variables points to that space in memory. In Python, we don't technically have variables, we have names. But you can absolutely still call them variables, and no one is going to yell at you for it. But the reason they are called names is because Python variables are managed using a table-like structure containing key-value pairs. The key is the Python name itself used in the Python code. The value is something called a PyObject, which stores the variable type, a reference count, and the value the name was set to in the Python code. The reference count keeps a track of how many references in Python are pointing to this object. If that count ever hits 0, then the PyObject will be removed from memory. When Python variables are reassigned, the original PyObject it is connected to does not get updated. Instead, a brand new PyObject is created. If you are reassigning a variable to another variable, then the latter variable's reference count will increase by 1. Either way, the reference count of the former PyObject is decreased by 1. I have an example of some assignments here. In this example, we have a variable x. Its first assignment is to the integer 5. When we create this, a PyObject will be created with the type integer, a reference count of 1, and then the value of 5. If we were to later reassign the x to the value of 6, a new PyObject will be created, again with integer, again with the ref count of 1, and then the value of 6. And then the original PyObject that had the value of 5 will get removed from memory. If we created another variable name, y, and we assigned x to y, a new PyObject will not be created. The PyObject that already exists that points to 6 will have its ref count updated to 2. And then we have y then updated so that it equals the value of 7. In this case, the PyObject for 6 will have its ref count updated back down to 1, and a new PyObject will be created for the value of 7 with a ref count of 1 as well. One other thing to mention, Python variables are dynamically typed as opposed to a statically typed variable like in C++. What does that mean? Well, in C++, when we want to create a variable, we have to declare it or establish its type. For example, if we wanted to create an integer x, we would have to, at a minimum, type int x. Or if we wanted to create an integer and assign it a value immediately, we would say int x equals 2, or some other integer. A Python variable is just a name referring to a location, so they don't technically have a type. It's the PyObject that they refer to that has the type. So whenever we analyze a Python variable to check its type, we're actually checking the type of the PyObject it refers to. And because Python variable names can be reassigned to different PyObjects, they can also potentially refer to different data types. We can assign a name x to the value of 2 and it will be considered an integer, but then we can later assign x to the value of spaceship or hello or something, and then it will be considered a string, such as what we have here. And here we have x equal to 2, and then we will print out x, and then later we'll assign x to the string hello, and then we'll print it out, and it will print out hello. And then this last line here is just me deleting x, so it doesn't interfere with any future examples. But if I run this and print it, As you can see, it printed out 2, and then it printed out hello. Now let's get into some actual programming. And we'll start with our first data type, the NoneType. So we can't create blank variables in Python like we can in C++. When we say, well, it's improper to call it a blank variable. It's actually uninitialized, and we can't use it until we initialize it in C++. But in C++, we can add a line int x, and it's basically uninitialized, not assigned anything. It would cause an error if we tried to use it, but it can be like that. In Python, we don't have a way of doing that. Since we don't really declare variable types in Python code, it's determined by what we assign it. Whenever we want to create a variable, we have to assign it something. We can't put a line like this in here, x, and then expect Python to be like, oh, that's an uninitialized variable. No, it won't like that. It will think we're trying to do something to x, but since x is not defined, it throws an error. If I run it, see, we get an error saying it's not defined. So the closest thing we can get to an uninitialized variable is to assign it the value of nothing, which is where the none type comes in. We can assign it with none, and it will be none. And if I run it, and it prints out, it just says, oh, this is none. This may seem useless at first, but there are a number of uses for the none type. But I won't get into them in this video here because they involve a number of topics that won't be covered until later videos. I just wanted you to be aware of this type in this video. Next up are the numeric types: integers, floats, and complex. We can use these numeric types for a number of things, including arithmetic operations. They are immutable, which means once they are assigned, the value cannot be directly modified. We can generate a new value using that value, but then we'd have to assign it to another variable in order for it to be permanent. So applying an arithmetic operation to, say, x, if it was equal to 1, in order for that to be permanent, we would have to store it back into x or store it back into another variable. Integers are pretty straightforward. They are non-fraction numbers that can be negative or positive: 0, 1, 2, 3, negative 65,783, and so on. In Python 3, there is no real maxed integer values. It can store large numbers based on available memory. And I've got a few examples right here. So we got an x equals to 2 and a y equals to 4. And I got a few arithmetic operations right here as well. So as you can see right here, that equals to 6, that equals to negative 2, and then we got 8, and this is 2.0. Now the reason why this comes out as 2.0 is because all division operations, regardless of whether you use ints, floats, or a combination of the two, will always result in a float. Which brings us to the next numeric type, floats. Float variables are used for precision decimal numbers like 1.0, 2.0, 3.14, or 76.23, and so on. Floats can be negative or positive as well, and they have a min-max range, which I have here in this comment. I'm not going to bother reading that out, but that is the min-max range. And then our final numeric type, complex. Now, I've never seen complex numbers used personally, as they are likely only used in programs that focus on mathematical tasks that would actually use them. I've never had to do anything like that. So because of this, I'm not going to go into too much detail on them. I just wanted to make sure that you were aware that they are something that actually exist in Python. Next up is the Boolean data type. Booleans can have one of two values, true or false. Booleans are used in test conditions that control whether or not certain code executes. Conditional tests will result in a Boolean value themselves, but Booleans can also be assigned directly as an indicator that something happened that needs to be tracked for code to check later on. And we'll get more into Booleans when we actually talk about conditionals, such as if statements and stuff. But I do have a few examples. Well, I have 2 examples because there's only 2 Boolean values possible. We've got an x equals true and we got a y equals false. I can print both of them out, and I've got an if statement right here. I'm going to change that to an x first. And basically what this if statement does, when you do an if statement, it's basically evaluating a conditional statement and seeing if it equates to true. In this situation here, I just put x as a conditional statement. So it's basically checking to see if true equals true. So when I run it, it will print out the message. Now, if I were to replace this with y, Again, instead of an actual condition to examine, I just put a Boolean value directly in there. So in this case, it's now going to see if false equals true, which obviously it doesn't. So when I run it, it won't print anything because the statement was not true. The last data type we have are strings. Strings are anything wrapped in single or double quotes. They are also immutable in Python. Strings can contain special characters, numbers, and alphabetic characters. And I have some examples here. I won't go too much into these because there is a lot to cover in strings, and I want to keep this video short. So we've got some simple string names. Most of them are just letters, but we've also got numbers. You know what? Let me add some special characters in here, just for the sake of showing that you can actually print them. And then we can have numbers and letters together, and we can just have straight numbers. As long as they're wrapped in quotes, they'll just be considered a string. And if I run this, as you can see, they all print out and everything like that. So a literal, before I forget, so a literal is what raw data is. Whether it's an integer, a float, a boolean, none, or a string, that is considered a literal. When we assign a literal to a variable, that variable is storing the literal. And it's not just data that we store into variables. Like this print statement here, this string right here is considered a literal in itself. Same with all the numbers and booleans and stuff that we just printed directly on the screen. We can also print out variables combined with other variables or with other literals. However, when we combine non-strings with strings, we have to take an extra step in order for them to print out without causing an error. And to show you what the error would look like, I have an example right here where we have an x equals to 45, and we're trying to print it with a literal, the word test. We get an error here. This is because x is an integer, not a string, and the concatenation symbol, which is a plus sign, cannot handle non-string being combined with a string. We have to manually convert that x to a string in order for this to work. And this is an example of casting, and there are other forms of casting which I will get into in another time, but for the sake of this, for strings, I will show you a string example for casting. So here we got a number of variables, and to cast, as you can see, I have wrapped the non-string variables with the keyword string and a set of parentheses. So these will allow these non-string variables to be combined with a string literal or a string variable. So if I run this, we get all these messages printed out. So x equals 45, y equals 3.14, test equals true, name equals Wayfair, and then this complex string I have here where I combine an integer with a string literal with a string variable with another string literal creates this sentence here, 45 ships at Wayfair station. And that's about it for basic data types. In the next variables video, we will be going over data structures. If you've enjoyed this video and found it helpful, then please leave a like and be sure to leave a comment below to let me know what you think. If you want to see more, then head on over to Wayfair Coding Academy channel to check out my other content. And while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you all next time.